In episode 12, we built a client that connects to one server and drives a tool calling loop. But in a real system, you have multiple servers: a file system server, a database server, a web search server. The model needs access to all of them at once. In this episode, we build an orchestrator that connects to the entire fleet, merges their tool lists into one unified catalog, and routes every tool call to the right server automatically. The orchestrator design has 3 layers. First, it manages a dictionary of named MCP clients, 1 per server. Second, it builds a unified tool list by prefixing every tool name with the server name separated by double underscores. A tool called read file on the file system server becomes file system double underscore read file in the unified list. Third, it has a router that strips the prefix from a tool call to find the right client and dispatches the call. The orchestrator takes a dictionary of server definitions at init time. Each key is a short server name, and each value has the command and args needed to launch it. We store 2 internal dictionaries. Clients map server names to MCP client instances. Tool index maps prefix tool names to a tuple of the server name and the original tool definition. Connect all launches all clients in parallel using async io.gather. The connect one method creates a client, connects and initializes it, then indexes every tool under its prefixed name in the tool index. The all tools method returns the complete unified list by spreading each original tool definition and replacing the name with the prefixed version. The model receives this list and sees a flat catalog of every tool across all connected servers. The double underscore prefix is the only visual indicator of which server a tool belongs to. The router is the cleanest part of the orchestrator. We look up the prefix tool name in the tool index to get the server name and the original tool definition. We retrieve the correct client from the client's dictionary. We call the tool using the original unprefixed name because that is what the server registered. The entire routing logic is 6 lines. The prefix scheme handles all disambiguation automatically. The agentic loop for the full fleet is almost identical to the single server version from episode 12. The only difference is that we call orch.allTools to get the unified list and arch.callTool to dispatch through the router. The model receives a flat tool list containing every tool from every server and can call any of them freely. When it calls file system double underscore read file, the router finds the file system client and dispatches the call transparently. Starting the fleet is 3 lines. Create the orchestrator with the server definitions. Call connect all which launches all 3 servers in parallel using async io.gather. Then pass the orchestrator to the agentic loop with a question. Here, we ask it to find all Python files and count them. The model will call file system double underscore list directory to explore the project. File system double underscore read file if it needs to inspect specific files and synthesize a count from the results. Always shut down server processes cleanly when the orchestrator is done. The shutdown method iterates all clients and terminates each sub-process. We wrap each termination in a try except, so one failed shutdown does not prevent the others from closing. In production, you would implement the async context manager protocol by adding async enter and async exit methods, so the orchestrator can be used in an async with block that guarantees clean shutdown even if the agentic loop raises an exception. You now have a multi-server orchestrator that starts an entire fleet in parallel, builds a unified prefix tool catalog, routes every call to the right server, and drives a complete agentic loop across all servers simultaneously. In the next episode, we tackle streaming and long-running tools. How to stream progress updates from a tool that takes minutes to complete without blocking the connection. Subscribe so you do not miss it. See you in the next one.